All right, guys, happy E-Day. We are going to finish up chapter 2 today, and we're going to talk about section 2.10, which is change expressed as a percent. So in other words, we're looking at percent change. So we have a formula for percent of change. And so what we're going to do here is when you have percent of change, you've got a new value and you have an old value or an original value. So we're looking at our original value and we're seeing by what percentage our value has increased or decreased to our new value. So really all we're going to do here is to find percent of change. We're going to calculate percent of change by doing the difference in the values. So we're just going to subtract those two values, and we're going to divide by the original value. So we're going to look to see how much it's changed by calculating the difference between the two numbers, and then we're going to divide by the original value, okay? And we're going to get some decimal. When we do that, we're going to get a decimal. So I want to change that to a percent. So whenever I want to change a decimal to a percent, I'm going to move that decimal 2 places to the right, or I'm just going to multiply that by 100. Okay, so whatever decimal you get, you're going to multiply that by 100, and that's going to be your percent of change. So that's our formula. We want to make sure we've got that formula nice and big in our notes here, because we're going to be using that throughout our section here. So let's go ahead and take a look at our first example. So I have a coat is on sale, and that coat's original price is $82, and it is now on sale for $74.50. So I want to figure out what the discount was, and we're going to express that as a percent. So again, with our percent of change, we're going to do the difference in the two numbers. So whenever we want to find the difference between two numbers, we're always going to take the bigger number minus the smaller number. Okay, so in this case, the bigger number is 82. So we're going to do 82 minus $74.50. And then we're going to divide by our original price. Now it says here in the problem, the original price is $82. So we're going to divide by 82. So that's how we would set up that formula. Okay, and that's going to give us a decimal, and then whatever that decimal is, we're going to want to multiply that by 100 in the end, and we're going to get that percent of change. So in the end, when I do this math here and multiply by 100, I get 9.146, and it just keeps going on forever and ever. Depending on what Math Excel asks you to do, you're going to round to a specific spot. So I'm just going to round to the 10th place here for right now. It may say differently on Math Excel, but it's going to be a 9.1% change. Now we also want to express it as either an increase or a decrease. Now since this is a sale, that means that we have our original price, and our original price got smaller. So the price got cheaper. It was cheaper. So it's going to be a percent decrease, meaning that percentage went down, or that value went down by 9%. Okay, so that's how we find our percent of change. We just subtract the two numbers, then divide by whatever our original price is. Let's go ahead and take a look at another one here. So a store buys an electric guitar for $295. The store then marks up the price of the guitar to $340. So anytime a store buys something, they're going to sell it for more than they actually bought it for, so they can make some money. So we're still going to find that percent of change here, but this time we might notice that the number is increased. So it's going to be a percent increase at the end. So to find the percent of change, we're going to subtract the two numbers, and this time we're going to do bigger minus smaller. This time we're going to do our new number minus our original. No, we always just want to do our bigger number minus our smaller number. And this time our original price is what they bought it for. So they bought it for $295. So hardest part about these types of problems is figuring out whatever that original number is. So I'm going to go ahead and then multiply that by 100 to get my percentage. So when I punch that in my calculator here, and then multiply by 100 to change that to a percent, and if I round that to the 10th place, I'm going to get 15.3%, and that is this time a percent increase. Okay, so this time our price went up. So they raised the price by 15% in order to make a little bit of money off of that guitar that they bought. So that's kind of how percent of change works. We may also see percent of change in a little bit different way by what's called percent error. So I'm going to put this up on the screen. You may need to pause the video to write some of this stuff down. But we have what's called relative error. And it's pretty much you estimate how much something is, and then you have the actual value, and then you can calculate the percent of error that you have from that. And if we look at the actual problem here, it's pretty much the exact same formula. If we look at it, it's pretty much the exact same formula as we had before. So this relative error formula is just another formula that we have here that we can use. Now, we have these fancy little things here. Those are called our absolute value bars. If you just do the biggest number minus the smallest number and then divide by the actual value, then we'll still get that value there, okay? So then we're going to take that relative error and we'll turn it to a percent. So then we'll multiply that by 100. Really, honestly, it's the exact same situation, the exact same type of thing that we're doing here. It's just the wording is just a little bit different because we have just a little bit different situation here, okay? So let's go ahead. If you need to pause the video to write some of this stuff down, go ahead and pause it. But we're going to go ahead and look at our next example here. So you think that the distance between your house and a friend's house is 5.5 miles. So you've estimated that the distance is 5.5 miles. The actual distance is 4.75 miles. So we want to find that percent error in our estimation here. So the way that we're going to do that is just we're going to calculate the percent of change. But this time we're just going to say it's percent error. So we're going to do the exact same thing. We're going to take the difference between the two numbers, and then we're going to divide by the actual value. Okay, so again, we're setting this up pretty much the exact same way, and then we're going to change it to a percentage, so we're going to multiply by 100 at the end. So we're going to take the bigger number, 5.5, minus the smaller number, 4.75, and then we're going to divide by the actual distance here. So the actual distance is 4.75, so we're going to divide by 4.75. And then I'm going to multiply that by 100 at the end to turn that to a percentage. Okay, so again, this looks very similar. If you look at this one compared to the other two examples we did, it's pretty much the exact same thing. It's just worded a little bit differently. Okay, so we're going to punch all that information in our calculator, and we get 15.8%. So you were off by 15.8%. Okay, so this is just an error of 15.8%. So that just means that you were close, but it was not the exact distance from your estimation. All right, last question we need to look at here. It says you are framing a poster and measure the length of a poster to 18.5 inches to the nearest half inch. So I want to know the minimum and maximum possible lengths of that poster. So we have a poster here, so I'm going to just go ahead and draw a rectangle poster. And we're measuring. And a lot of times when you measure, we don't necessarily measure perfectly. There may be a little bit of an error here. So we measured this out as 18.5 inches. Okay, one of the dimensions that we have here is 18.5 inches. And it says to the nearest half inch. Okay, so that means that your measurement, it only has a half an inch range. You know that if you're off, you're only off by about half of an inch. Okay, just by eyeballing it and measuring it, you're only off by about half of an inch. Okay, so what we're trying to find here is the minimum and maximum possible lengths. So to do that, it says we're off by half of an inch. So really what we have here is we're going to imagine 18.5 is like right in the middle of what all of our possible values would be, okay? So since it's a half of an inch, that means that I can take 18.5, and to find the minimum value, I'm going to subtract half of our total amount. So since we have half of an inch, that means we could go a quarter of an inch below that measurement, or to find the maximum, we can go a quarter of an inch above that maximum. Okay, so the minimum value that we could have is 18.25 inches. And then the maximum value we could have there is 18.75 inches. And you might notice that those two values are a half of an inch apart. So that's what it means by to the nearest half of an inch. We are measuring and we have a half of an inch range that our values could be there. So it may not always say half an inch. It might say like to the nearest full inch, or to the nearest full whatever units we're using there. But we just take that amount and split it in half, and then you're taking above and below that measurement there. Okay. So that is all we have for this section here. There is a practice on Math Excel that we should be working on after this, and if you have any questions, feel free to reach out, and we will discuss anything that we need to discuss from this section when we come back to school on Thursday. Have a great rest of your E-Day.